Pressure Chicks. It's Robin here, and we're doing 3 experiments that have to do with pressure. Pressure as defined by Oxford means continuous physical force exerted on or against an object by something in contact with it. Without further ado, let's get on with the first experiment. For our first experiment, we're doing the ping pong funnel. We have 3 materials that we need for that: a ping pong ball, a bottle, and a knife to cut the ball. So we're first going to cut it right here. Now that we have our funnel cut, let's move on to the basics of our experiment. So we have our funnel, and we're going to put the ball inside of it. And then we're going to blow onto it. What do you think is going to happen? Let's test it out. So why didn't it go out of the funnel? The air is flowing up the funnel because we are blowing air into it. This creates low pressure under the ball. Blowing it makes the moving air molecules go faster, resulting in the low pressure. The low pressure zone under the ball and the high pressure zone on top of the ball results in the ball going down and not up. That is why the ball cannot get blown out whenever you blow into the funnel.
Hiya, Callista here of Pressure Chicks. I also have an experiment for us to do. What you're going to need for this experiment is 1 cup or glass. I have here a yellow cup. You will also need some sort of playing card, or card in general. I have here an Incredibles 2 playing card that is a 6 of clubs, in case you were wondering. You can also use an index card, but make sure that water isn't going to seep through the paper, so make sure it is thick enough. For this experiment, we're going to be filling up this cup half full with water. And then we're going to put the card over the opening. And then we're going to flip it and see what happens when I remove my hand. Now, make a hypothesis about how this will work. Alrighty, let's test it. As you may or may not be able to see, I have filled this cup half full with water. I'm now going to be putting this card over it, making sure that no part of the opening of the cup is exposed. So no water can seep out. And we're going to flip it on 3. 1, 2, 3. And then I'm going to remove my hand. Watch very closely. It stayed. Hopefully you hypothesized that. Now, how does this work? Let's get into that.
When looking at this, it can be puzzling. Wouldn't the water be too heavy and push the index card, making the water fall out? No. We have atmospheric pressure, which is about 15 psi, pushing the index card up. Now, look at the open space at the top, formerly bottom, of our cup. We have air up here. Before you flip the cup over, the air pressure inside and outside of the cup are the same. However, when you flip the cup, the water shifts ever so slightly, and the space in which the air molecules had to roam free increased. Therefore, the molecules spread out, and this decreased the pressure a bit. Since objects are always moving towards the low pressure areas, the card is pushed upwards, but not enough that it collapses into itself and splashes the water everywhere. For our final experiment, you're going to need a knife and something to cut. We use an apple. This experiment is all about surface area and how it relates to pressure. What you're going to be doing is you're going to be trying to cut your fruit with the dull side of the blade and with the jagged edge of the blade, and you're going to see which cuts better. So go ahead and make your hypothesis about what you think will cut easier. When we try cutting with the jagged edge, it works very well. This is because the surface area is a lot different. It is smaller, so there is a higher pressure zone pushing into a low pressure zone, therefore cutting the apple. As you can see, when we try to cut through the apple, it doesn't really work very well when we use the dull edge. This is because the more surface area you have, the less pressure you have, and you need a lot of pressure to cut through an apple, because an apple is hard. That's it for Pressure Chicks. See you next time.